talk to them about our square. How do we know it's a square? What makes it a square? We would bring in some previous vocabulary from earlier grades. They've known square since kindergarten. So we talk about it has 4 sides, all 4 sides are the same. It has 4 angles. It has 4 vertices. It has 4 right angles. Those are all from primary grades, knowing what right angles are. We could bring it back to that. And what are some ways that we could prove it's a square? We might hold up a shape that's not a square, like a rectangle, and we could talk about how when we fold it diagonally, we might have to talk about what diagonal means. We're creating a line of symmetry where both sides will be the same, or will be the same on, there will be reflections of each other. Well, obviously when we fold a rectangle, it doesn't make 2 congruent triangles. It doesn't make 2 congruent sides, but when we fold a square, it does make 2 congruent sides. Get another square. And so we go ahead and do that, fold it along the diagonal, and then talk about that line of symmetry. Talk about how I've created 2 triangles. How do you know they're triangles? What makes them a triangle? A triangle has 3 sides. It has 3 angles. It has 3 vertices. And we know that they're congruent because they're the same size and the same shape. So a square will create 2 congruent triangles when we fold it on the diagonals. We're going to go ahead and do that. While we're doing this and the kids are doing it, we want to bring out that vocabulary. So I want to start by going ahead. We've cut them, and now once again we can talk about how we know they're congruent, because when I take the 2 together and I put them together, it looks like one triangle. They're the same size and the same shape. So I'm going to take one of my, I also want to talk about how they are called isosceles triangles. And we would talk about what that means, because that would be new learning for 5th grade. Isosceles triangles means that 2 sides are the same and 2 angles are the same. So we might talk about which angles are different, which angles are the same, and we could use one triangle to confirm that. So we could say, like, we know that this side is the same as this side, and we could confirm that with the other triangle by testing it out and seeing that they're the same size. This is the same size, but when we compare these, we can see that one side is longer. So 2 sides are equal, and one side is of different length. So that's what isosceles triangle means. So we're going to take one of our isosceles triangles, and we're going to fold it in half. Again, making a line of symmetry so that we are creating 2 congruent, excuse me, 2 congruent triangles again. And we would talk a little bit about the triangles the same way we did the others, that we've created 2 that are the same. They're also both isosceles triangles. And now we could talk about how we know they're congruent once again by putting them together and seeing they're the same size and same shape. Comparing the sides again, this side is the same length as this side, but this 3rd side is different. We could also say that it's a right triangle because it has a right angle. And they don't have to know this in 5th grade, but they could talk about how this long side is called the hypotenuse. But we know that it's a right triangle because it has one right angle right there. And we can also talk about how these are both similar triangles. And similar means that they're the same shape, but not necessarily congruent. They're not congruent. They're similar. They're the same shape, but they're of different isosceles triangles, but one is larger than the other. So we talk about how similar is different from the word congruent. We're going to take our other large isosceles triangle that we have not labeled yet, and we're going to put the long side, the hypotenuse, towards our stomach like this. And we're actually going to take this vertex here and fold it right down the middle, right down to the center point of this long side. So imagine this is the center point. We're going to fold that right down there and make it touch. So what we're creating here is a triangle folded over top of a trapezoid, like that. And we're going to actually cut that. So we've taken the large triangle, we folded it down. We're going to cut that. And again, we're going to talk about what shapes we've created. We have another isosceles triangle, just like the others that we had cut. They're similar but not congruent because they're not the same size. They all have right angles. This has a right angle. And now what we have left is our trapezoid. So we want to talk about how we know it's a trapezoid. We know that a trapezoid has 4 sides. Let's count the 4 sides. What else do we know about a trapezoid from 4th grade? Again, this is a review. That has exactly 2 parallel sides. And what does it mean to be parallel? That they have equal distance from each other. So this line and this line, or this side and this side, are parallel to each other, but these 2 sides are not parallel to each other, and that's what makes a trapezoid. So we're going to take our trapezoid and we're going to, again, fold it into a line of symmetry so that we have 2 equal sides, 2 congruent sides. And we're going to cut that one like that. And again, we can compare and show that they're congruent by placing them together. See, they have the same size and the same shape. Talk about what this shape is. What would we call this shape? Anybody have any ideas about that? Let's count the sides that it has. It has 1, 2, 3, 4 sides. It also has 2 sides that are parallel to each other and 2 that are not parallel to each other. So what would we call that? That's also called a trapezoid. It looks different from the original trapezoid we have, but we know that it's a trapezoid because it meets the rules of trapezoid. 4 sides, exactly 2 of them are parallel. So it's just a different shape of trapezoid. And what we're going to do, I gotta remember how to do this. We're going to take the we're going to imagine this is the shoe. This is the toe of the shoe, this is the heel of the shoe, and this is the top of the shoe, and this is where the shoestrings might go. We're going to take the heel of the shoe, and we're going to fold it up and make it match up to this side here, so that it makes another isosceles triangle. And we're going to unfold it like this, and we're going to cut it along that line. And now we've got another isosceles triangle that again is similar to the other isosceles triangles that we made. Similar but not congruent because it's the same shape but not the same size. We're going to label that one number 4. And then this shape here, we're going to call it our parallelogram, and we're going to remember back from 4th grade why it's called a parallelogram. It has 4 sides. What's another name for it? It's also a quadrilateral because it has 4 sides, but a parallelogram has 4 sides, and it has opposite sides that are parallel. So we're going to label that number 3. And now we're finally going to get to this last trapezoid that we have here. I can remember how to fold that one. Yes. And this time we're going to imagine this is the shoe again. Here's our heel, here's our toe, here's the top of our shoe, here's where our laces would go. This time we're going to take the toe of the shoe, and we're going to make the toe fold all the way back to the heel. So the toe and the heel touch each other like that. And now what we've done is we've made one more isosceles triangle folded over top of the square. And we can see that when we open it up. We're going to cut that right along the line. We're going to label the smallest triangle number 6. And we're going to label the square that we have left number 5. And we can also talk about how the 6 and the 4, what would we say about the 6 and the 4, that they are also congruent. The 6 and the 4 are congruent to each other, they're the same size and shape. Number 1 and 2 are congruent to each other, they're the same size and shape. Number 7 is similar to the small ones, but not the same size. Number 7 is similar to the big ones, but not the same size. So it doesn't have a match. And what we've ended up with is 7, tangram shapes. We have 2 large isosceles triangles, 2 small isosceles triangles, 1 medium-sized isosceles triangle, 1 square, and 1 parallel. While I'm bringing out the review vocabulary through the lesson, and when I introduce the new words like isosceles, I would put those up on the board as I was talking and while the kids are cutting and while the kids are folding, but I wouldn't have them stop and do that yet. I would have them do that at the end of the lesson because I don't want them to lose the flow of the lesson and where they are in the folds while they're trying to get it down on paper. So I would put the words up there so we can keep looking at them and reviewing back to them, and then we could come back to those at the end where they could put them in a notebook or like get the vocabulary down in their journal. So the next challenge I would have them do is, now that we have them all labeled, is see if you can rebuild the square. There it is.
Got it?
Okay.
Okay.
Now I've got, there we go. Yeah, that's it. So there's my square.
Mm-hmm.
Okay, so let the kids go ahead and try to rebuild the square and let them have some fun with that. Because the next thing they're going to do, and you know, depending on your kids, you might want to do this over 2 days. Like when I've done this with 5th graders, we did this over 2 days because it took them a while for us to have those discussions, because even though I did it really quickly with you, I would be stopping along the way. And when we cut those triangles, we're going to have a lot of discussion about how do we know that these are congruent. Turn and tell your neighbor why you know that. What can we say about number 6 and number 1? How do we know, what word can we use to describe them? We could say that they're isosceles triangles. We can say that they're similar, but they're not congruent. But those are things I would have kids doing along the way, stopping and talking. Turn and talk to your neighbor. How do you know? How do you know? And so if you're doing a lot of interactive questioning and feedback, it would probably take a while to get through this. So you might actually wait until day 2 to do the problem. But the problem becomes this up here on the board. So we've identified each piece of the triangle, which pieces have the same area, and how do you know? If the area of number 5, the small square, is worth 1, what would we say is the area of all the other pieces? Well, this is where they're going to have to do some serious problem solving here, because none of the other shapes match this. So how would we determine that they have the same value or the same worth? And we might even put, I've done it where we give a value of this is worth $1, what is all the others worth? So one of the things that they can do to solve this is to do some folding. So for example, I might, if kids are stuck, I might say to them, if we folded this, could we say that there's any relationship between this one and this one? And they might say, oh, well, the triangle that you made was worth half of the square. So if I unfold the other piece of it, if there's 1/2 of the square and there's 1/2 of the square, what could we call that? We could say that's 1 whole square's worth. And if they still weren't sure, they could have another piece of paper, another set of tangrams that you might actually just pass out to them already cut. They could cut that piece and rebuild those 2 triangles to make that square and prove that this is half and this is half, and it makes 1 whole square. So they have the same value. They're not the same shape, but they do have the same value. They have they take up the same amount of space, and we can prove that by doing some folding. We could do the same here. We've got this number 7 and this number 1, for example. Do you see any relationship between them? And they might lay it down, and well, what would happen if you rotated it? Again, you're bringing back some of that 4th grade vocabulary. What happens if you rotate it? What if you rotate it again? Oh, well, now we might see, oh, it fits nicely right there on the side. I wonder, can you make any relationship? Well, it looks like it's half. Let's see if it's half. Let's fold that and say, oh, yep, it is worth half. So if we know that this triangle is worth half of this one, we could say that this is double this. So we're making some relationships here. Well, we already said that this 7 is worth the same as the square. So if this is worth 1, we already said this is worth 1, and we would be writing those on the back, by the way. This is worth 1, and we also know this is worth 1. But we also know it takes 2 of these to make this, so we could say 1 and 1, we know this one is worth 2. And you can do that with all of the shapes, the same with the small triangle. Is there any relationship? We know the value of the square is 1. how is this triangle related to it? Oh, it's worth half as much, and we can prove that again by folding it. Yes, it would take 2 of these triangles to make 1 of these squares, so we know that this is half as much. So if this is worth 1, this would be worth 1/2. And again, we could find some relationship between the small one and the parallelogram, or the quadrilateral. We can lay it on top and see that, oh gosh, it fits really nicely on half of this parallelogram, and we want to prove that it's half. We could fold that over and say, oh yeah, it's the same shape. Or I could lay 2 of these small triangles down on top of it and see that there's 1/2 and there's 1/2, and so 1/2 and 1/2 also makes a whole. Well, isn't that interesting? This one is worth 1. This one's also worth 1. This one's also worth 1. All of these are worth 1. They take up the same amount of space, but they're all different shapes. So that's what they do with this problem. They have to determine, if I know what the square is worth, how could I determine the worth of all of the other pieces? And they can do that by folding and cutting. But what I would recommend is actually having a set that they use from the day before or the earlier in the lesson, and then maybe another set where they could cut up to do some experimenting with.